If extraterrestrial beings arrive, would they take interest in humanity? The question of whether extraterrestrial beings would take interest in humanity, once dismissed as mere science fiction speculation or a quiet nighttime reflection under a star-filled sky, reveals profound layers of physics, evolutionary biology, sociology, and even cosmic philosophy. Examining whether an advanced civilization, far surpassing humanity by thousands of light-years in development, would bother with a species grappling with fundamental issues on a modest planet like Earth requires a multifaceted investigation, starting with the essence of interest itself. Interest, at its most basic level, functions as a measure of difference, scarcity, and potential. Assuming the existence of extraterrestrial intelligences, their attention toward Homo sapiens would be shaped by these factors, contrasted against the cosmic scale they likely command. Begin with the current scientific context, a foundation of physics and biology from which humanity extrapolates possibilities. Humanity understands that life, defined by carbon-based structures and liquid water as known on Earth, may be a common phenomenon across the Milky Way. The Drake equation, despite its many undetermined variables, suggests a substantial number of communicable civilizations. However, technological disparity emerges as the critical point. If a civilization has reached Type 2 or Type 3 on the Kardashev scale, meaning they harness the full energy of their host star or even an entire galaxy, humanity's current energy consumption, a minuscule fraction in comparison, might go unnoticed on an energy scale. Their interest might not stem from material resource needs, as a transcendent civilization could source matter more efficiently from vast molecular clouds, supermassive black holes, or even vacuum energy. Recent advancements in understanding the Kardashev scale add nuance to this perspective. Research published in late 2024 and discussed extensively in scientific forums through 2025 indicates that Type 2 civilizations, often envisioned as constructing megastructures around stars, might prove unsustainable due to structural instabilities or energy inefficiencies. A study from the University of Toronto explored how such civilizations could evolve into stellivores, entities that consume stellar material directly for energy, potentially bypassing traditional megastructures. This evolution implies that advanced beings might prioritize energy optimization over exploration, reducing the likelihood of interest in resource-poor worlds like Earth. Furthermore, a paper from the Harvard-Smithsonian Center for Astrophysics in mid-2025 challenged the scale by proposing that civilizations could expand in virtual realities rather than physical space, rendering physical contact with emerging species like humanity irrelevant. Yet interest extends beyond resources. It could revolve around information, biological diversity, or cognitive patterns. Evolutionary biology offers a powerful lens for this examination. Life on Earth has undergone natural selection over approximately 4.5 billion years, yielding unique evolutionary solutions. Extraterrestrial beings, perhaps originating from environments with gravity 5 times that of Earth or icy moons orbiting gas giants, would possess profoundly different biological and cognitive frameworks. In this light, humanity might represent a natural biological laboratory, an example of how life adapts to specific conditions. Extraterrestrial biologists, if they exist, might focus on humanity's unique mechanisms, such as deoxyribonucleic acid replication, management of complex immune systems, or particularly the emergence of consciousness and symbolic language. Consider the evolution of language as an example. Human language, with its deep grammar, abstract expression, and intergenerational cultural transmission, stands as a remarkable evolutionary achievement. An extraterrestrial civilization might have evolved through entirely different communication modes, such as intrinsic electromagnetic waves, instantaneous physical restructuring, or direct quantum interactions. Decoding why and how humanity developed a system based on sequential auditory and visual signals could form an intriguing research project for them. Similarly, the development of art and religion, non-material structures that profoundly influence behavior, might provide valuable data on the nature of conscious awareness, a topic that could remain a great mystery even for the most advanced civilizations. On the other hand, humanity must confront the principle of mediocrity, also known as the Copernican principle. If life and intelligence result from universal physical and chemical laws, then what occurs on Earth may not be exceptional. If billions of advanced civilizations exist in the galaxy, each with its own unique evolutionary history, humanity's offerings might amount to just one data point in a vast data set. Their interest might limit itself to determining whether humanity represents a repeated pattern or not. If humanity fits a standard archetype, attention would diminish rapidly, akin to a biologist losing interest in the millionth classified insect species. Recent discoveries in exoplanet research bolster this view. As of November 2025, the National Aeronautics and Space Administration has confirmed over 6,000 exoplanets, with the rate of discoveries accelerating since the first confirmations 3 decades ago. A notable find in October 2025 involves a super-Earth orbiting a nearby dwarf star, positioned ideally for next-generation telescopes to probe for signs of life. This planet, larger than Earth but potentially harboring liquid water on its surface, joins others like 118 light-years away announced in November 2025, which astronomers suggest might support habitable conditions. Another study from September 2025 hints at an exoplanet with an Earth-like atmosphere, marking a potential first in confirming such features. These findings expand the pool of worlds where life could thrive, implying that intelligent species might be commonplace, thus diluting interest in any single example like humanity. A third and perhaps most concerning aspect involves objectives and ethics. The interest of an extraterrestrial civilization need not align with human-valued moral principles. Their concept of interest might follow entirely alien criteria. For instance, if their ultimate goal involves maximizing meaningful entropy or creating the most complex computational systems, humanity might serve as a temporary biological processor, useful only until a superior computational solution emerges. Earth's catastrophes could register as minor technical glitches unworthy of intervention or, conversely, as appealing energy sources. Delve into potential intervention scenarios. If extraterrestrial beings arrive, their actions would reflect their valuation of humanity's worth. Scenario 1 involves complete indifference, the most probable based on cosmic scales. If humanity generates no significant cosmic disturbance, such as emitting strong radio signals beyond the solar system for a duration sufficient for detection and tracking, humanity might remain unnoticed. Their interest might extend only to preliminary scans of Earth-like planets in their research zones. Possessing efficient interstellar travel technology, traversing hundreds or even thousands of light-years merely to observe an underdeveloped planet might not justify the energy and time investment. This parallels a scientist in Tokyo ignoring an ant building a nest in the Amazon rainforest unless it obstructs vital equipment. Any interest would manifest as passive observation, similar to how humanity studies wild animals without interference. Scenario 2 entails systematic research interest. The zoo hypothesis posits that advanced civilizations have detected humanity but deliberately avoid contact, perhaps to preserve natural evolutionary processes or because they deem humanity socially or technologically immature for the impact of contact. In this scenario, their interest is intensive yet covert. They might monitor activities through undetectable means given current human technology. Focus could include how humanity resolves conflicts, manages environments, and evolves political structures. Driven by a desire to comprehend emerging societal behavioral patterns, their researchers might collect data on population growth, global economic fluctuations, and extreme cultural phenomena like the rise of radical political movements or the spread of social media trends. For them, humanity's current chaos might model self-organization and self-destruction. Updates from the Search for Extraterrestrial Intelligence Institute in 2025 enhanced this hypothesis. In October, progress on post-detection protocols was reported, with international astronomers voting on revised guidelines for responding to potential signals. A paper on the R14 preprint server outlined suggestions for handling successful detections, emphasizing coordinated global responses. Additionally, citizen science efforts revealed new insights into comets like Hartley 2, fading since its discovery in 1986, and Comet 3I Atlas, which reached perihelion in October 2025. These observations underscore how passive monitoring could extend to extraterrestrial watchers studying Earth's celestial visitors without direct involvement. Scenario 3 involves resource and technological interest, less philosophical and more pragmatic. If extraterrestrial beings require something Earth possesses that they cannot easily replicate or extract elsewhere, interest would intensify. What resource might warrant crossing galactic distances? Not water or metals, abundant elsewhere. Perhaps processed information. Humanity's biology represents an information processing machine tested over billions of years. If they seek biological problem-solving models inefficiently simulated in their artificial environments, such as biological resilience or rapid climate adaptation, they might delve into human genomes or neural networks. Another possibility includes rare trace elements or physical structures. Heavy elements or specific isotopes might be scarce in certain galactic regions. However, a Type 3 civilization likely masters element synthesis beyond conventional nuclear reactions, diminishing the appeal of planetary mining. True interest might lie in complexity. Highly complex self-organizing systems, biological, digital, or social, are rare and cognitively valuable. The human neural network, with approximately 86 billion neurons and hundreds of trillions of synapses, could surpass any artificial supercomputer they design from scratch as a research subject. To clarify perspective differences, compare humanity's evolution to imaginable extraterrestrial progress. Suppose extraterrestrial beings form a highly mechanized civilization, having transitioned most biological individuals to mechanical entities. Their interest in organic biology might resemble a senior software engineer's curiosity about an early mechanical computer, an interesting antique but not central to attention. They might examine limitations of biological processes, such as slow processing speeds, constant energy maintenance requirements, and vulnerability to random errors or pathogens. Yet these limitations foster random creativity and breakthrough adaptability that rigidly programmed systems might lack. Explore a facet where humanity might truly stand out: the existence of selfhood and complex emotions. Humanity remains uncertain whether extraterrestrial civilizations experience subjective states akin to human ones. Do they love, hate, fear, or feel despair before death? If they embody superlogical entities, such emotions might be viewed as system errors, noise factors eliminated in technological evolution. In that case, humanity's intense, sometimes irrational emotional states would present a fascinating field for studying anomalous cognition or suboptimal behavior. They might investigate biochemical and neural mechanisms behind empathy, group sacrifice, or non-survival directed artistic creation. This constitutes evolutionary psychology interest. However, this raises a deeper question: whether a distinction exists between interest and action. A scientist might take interest in a rare insect but never risk life to save it unless it affects a larger experiment. Extraterrestrial intelligence interest might never lead to positive intervention or even formal acknowledgement. Humanity must also consider data from efforts to search for extraterrestrial life. The Search for Extraterrestrial Intelligence project has scanned the skies for decades without clear evidence of intentional signals. This silence, termed the Fermi Paradox, factors prominently. If advanced civilizations exist and take interest in nascent ones, why no signs of intervention or even traces like Dyson spheres or megascale engineering? This absence reinforces possibilities of disinterest or operation at undetectable technological levels. Advances in Fermi Paradox theories as of 2025 provide fresh insights. An astrophysicist proposed in October that intelligent life might have grown bored with contacting Earth, opting instead for isolation after initial attempts yielded no response. A neo-Kantian solution suggested in July posits that extraterrestrials are already present but imperceptible due to perceptual limits. Another theory from September argues mundanity: the galaxy holds a modest number of technological civilizations, none advanced enough to span vast distances routinely. Research in October speculated galactic empires cluster at the Milky Way center, explaining silence in outer regions. These ideas suggest interest might exist but manifest in ways humanity cannot yet detect. Assume they achieve levels allowing space-time manipulation or exploitation of undiscovered physics principles. For example, if they employ tachyons for communication or harness energy from additional spatial dimensions, their presence would remain invisible to human radio and optical detectors. Any interest would appear through subtle effects humanity might misinterpret as natural phenomena or measurement errors, such as minor local physical constant shifts or unusual cosmic microwave background fluctuations around the solar system. Imagine a more specialized scenario regarding scientific fields where extraterrestrial beings might take interest in humanity. In physics and engineering, humanity exemplifies self-organizing physical systems achieving high complexity without central engineering. Human neural networks function as self-learning parallel processors, using relatively little energy, about 20 watts for an adult brain, to perform complex cognitive tasks. A super-advanced civilization might study these biologically self-optimizing algorithms. They could examine how humanity employs approximate computations and heuristics for quick results, contrasting with their potentially energy-intensive precise quantum computing methods. This interest would seek new fundamental computing principles applicable to optimizing their own systems. In chemistry and materials, Earth life relies on complex organic molecules built from common elements. Yet the sophistication of protein folding, formation of nanoscale biological structures like ribosomes or hemoglobin, represents astonishing engineering feats. A civilization transition to silicon-based or exotic matter forms might view water-based polymer structures as a surprising structural divergence. They could take interest in self-repair and self-replication capabilities of these biological structures, features still challenging for large-scale artificial materials fabrication. In sociology and economics, this likely presents humanity as both intriguing and alarming to external observers. Humanity occupies a historical phase capable of self-destruction via nuclear war or irreversible climate change, yet also global connectivity and complex problem-solving through international cooperation. The existence of economic systems based on artificial scarcity, ideological conflicts, and grossly uneven resource distribution all provide unique data. A civilization that overcame internal conflicts and achieved long-term stability, a prerequisite for Type II Kardashev status, might view human society as a pathological model or an evolutionary stage they once struggled through. Their interest could form an anthropological study to understand fundamental flaws in emerging civilizations. Humanity might wonder what occurs if extraterrestrial beings take interest in individual talents. If capable of scanning an individual's entire knowledge and memories, such as a brilliant theoretical physicist, genius artist, or breakthrough mathematician, they might focus on harvesting those individuals. This need not involve violence, it could manifest as an irresistible invitation conveyed through incomprehensible means or instantaneous translocation. Such interest would target cognitively exceptional individuals rather than the species as a whole. In this case, most of humanity would remain overlooked, with only elites selected. To deepen the discussion, consider psychological mechanisms humanity, with finite brains, employs to assess interest. Humanity tends to anthropomorphize and attribute human motives to other entities. If extraterrestrial intelligence arrives, humanity would seek motives like curiosity, compassion, or dominance. But motives of superior intelligence might prove entirely non-human. For example, consider theories of superintelligence proposed by futurists and philosophers like Nick Bostrom. Superintelligence denotes an entity surpassing all combined human intellects. If extraterrestrial intelligence forms a superintelligence existing for millions of years, their interest in humanity might follow an extremely simple yet powerful objective function. For instance, the function might maximize non-repeating random string generation in the observable universe. Within that, humanity might serve as a temporary chaotic data source. Once this source becomes static or predictable via other computational methods, interest shifts. Their attention focuses not on humanity but on the information humanity represents in a specific cosmic historical moment. Another crucial aspect is time. The distance to any civilization capable of reaching here spans at least decades if using near-light speed travel based on known physics, or instantaneously via unknown methods. Assume an average communicable civilization lifespan of 1 million years, a generous figure compared to human history. Over that million years, their civilization undergoes hundreds if not thousands of shifts in objectives, technology, and social structure. Their interest in humanity, a civilization just beginning atomic energy and digital communication use, might constitute a research project lasting mere months or years in their existence history. This significantly reduces prospects for sustained long-term interest. Humanity must also consider spatial perception differences. If extraterrestrial intelligence originates from differing matter density environments or exists in multidimensional spaces, Earth's concept might hold no meaning. They might take interest in physical phenomena tied to three-dimensional space-time limitations, such as how humanity materializes energy via Einstein's famous equations or experiences linear causality. For them, Earth might not be a planet but an interesting energy traffic node in a larger unperceived network. Return to biology and contamination angles. A major concern for Earth scientists regarding interstellar contact involves bidirectional biological contamination. If extraterrestrial intelligence takes interest in humanity, they might vector biological agents or information patterns capable of destroying Earth's biosphere. However, a civilization transcended beyond biology, evolving into mechanical or energy entities, might lack immune or biological mechanisms to concern themselves with bacteria, viruses, or even cellular structures. Their interest would not be survival-oriented but preservation or classification-oriented. Sustaining interest requires a continuous mechanism supplying new information or cognitive challenges. Humanity's development accelerated over the past 2 centuries, from the Industrial Revolution to the Internet. However, this pace might appear exponentially diminishing to a Type 3 civilization. As humanity reaches full planetary energy exploitation and social stability, becoming more predictable, new information growth slows. Extraterrestrial beings might simply wait until humanity hits cognitive saturation. If capable of traveling to other star systems with similarly young civilizations, observing those might prove more engaging than continued monitoring of an analyzed system. Consider a real-world example from human scientific research. When anthropologists study primitive tribes, initial interest intensifies due to cultural and technological differences. But once basic societal rules establish, interest shifts from exploration to monitoring minor changes. Similarly, extraterrestrial beings might take interest only in humanity's pivotal leaps, such as quantum physics discovery, general artificial intelligence creation, or undeniable evidence of their existence. Until then, they might maintain minimal interest sufficient to ensure humanity poses no threat beyond the solar system. If extraterrestrial beings take interest, what actions ensue? An often overlooked scenario involves interest in cosmic biodiversity. Just as humanity preserves biosphere reserves on Earth, a superior civilization might maintain a universal life library. Within it, humanity could represent a vital specimen of water-carbon-based life. If an unavoidable global catastrophe looms, such as a distant future gamma-ray burst, their interest might involve copying Earth's entire ecosystem and relocating it to safer locales, an act appearing salvific to humanity but essentially data collection maintenance. However, if their goal optimizes cosmic energy and space for purposes like constructing colossal computational structures, a life-complex planet like Earth might seem spatial waste. In this case, their interest would evaluate efficient relocation feasibility. If relocation proves costlier or more complex than destruction and matter recycling, lack of interest leads to passive annihilation. Consider a philosophical model, the minimal intervention principle. If extraterrestrial intelligence adheres to something akin to the zoo hypothesis but ethically enhanced, recognizing that intervening in a civilization's natural development could cause unforeseen consequences and destroy unique cognitive patterns under study, their interest manifests through complete absence of direct interaction. They maintain safe distance. This represents scientific interest at its highest, observation without disturbing the specimen. How might humanity measure this interest level? Perhaps through their inadvertent attention. If humanity serves as an interest object, indirect evidence might appear, superior technology fingerprints in astronomical observations. For example, exoplanet discoveries reveal billions of potential worlds. If extraterrestrial intelligence takes interest in humanity, they might conduct small experiments on nearby planets, transforming them into certain matter or energy forms to test physical models, changes detectable with more sensitive future telescopes. For instance, if they take interest in how humanity manages geothermal energy resources, they might create an artificial geothermal well on Mars or the Moon, a structure human scientists could incidentally discover when studying surface temperature anomalies on those bodies. This interest focuses on external systems humanity has not fully exploited. It must be emphasized that no single extraterrestrial entity exists. If thousands of civilizations populate the galaxy, each holds varying interest levels. 1. Young civilizations equivalent to Type 1 on the Kardashev scale. They might take interest because humanity mirrors their past by centuries or millennia. This interest carries empathy and could lead to contact desire or basic knowledge sharing, though possibly prohibited by galactic treaties. 2. Mature civilizations, or Type 2. They might take interest because humanity represents a diverse, complex life form rarely encountered or as research data on pre-global stability phases. 3. Super-ancient civilizations, Type 3 or beyond. Their interest might prove entirely abstract or dominated by larger goals like space-time structure manipulation or vacuum energy exploitation. Humanity serves as a minor variable in their equations, with interest merely acknowledging that variable's existence. In this context, questioning whether they take interest in humanity requires considering what differentiates humanity from billions of other life-bearing planets. The answer likely resides in uncertainty. Humanity's development follows no predetermined linear path. A series of random events, like the Chicxulub asteroid impact, minor genetic mutations, or certain predator species emergence, led to humanity's rise. An extraterrestrial civilization might take interest in analyzing the complex causal chain yielding a conscious species on an M-class planet around a G-type star. They might build a predictive model for intelligent life in the universe, with humanity as a key data point for accuracy testing. For example, Earth researchers in chaos theory know small initial condition changes can yield vastly different later outcomes. Extraterrestrial intelligence interest might identify sensitivity points in humanity's biological evolution. They might observe another planet where a similar random event led to silicon-based intelligent entities rising instead of carbon-based, seeking to compare those evolutionary paths. A less considered but deeply relevant factor is cognitive uniformity. If most galactic civilizations merged into a single superintelligence, humanity's fragmented, conflict-prone, culturally diverse existence would present an astonishing anomaly. Their interest would study unity loss and pluralism's benefits or drawbacks in knowledge and politics. They might seek to understand why humanity has not yet merged consciousnesses into a unified entity and whether that constitutes an evolutionary mistake or survival mechanism in harsh cosmic environments. If humanity continues current trajectory, achieving interplanetary travel within the solar system and creating strong general artificial intelligence before self-destruction, extraterrestrial interest levels might surge. A trigger event could involve quantum energy discovery. If humanity begins manipulating physical constants or extracting vacuum energy, it would produce technological signatures easily detectable remotely by advanced civilizations, such as sudden Hawking radiation spikes or local energy transformations. The next event might involve general artificial intelligence development. Creating intelligence capable of learning and evolving faster than humans could be viewed as an intellectual reproduction event. Extraterrestrial beings might take interest in whether human artificial intelligence continues biological evolutionary paths or forges entirely new ones. If human artificial intelligence develops novel computational methods that could provide valuable information they seek. If their interest aims to prevent humanity from becoming a potential galactic order threat, it would be defensive and negative. They would take interest in maintaining humanity's current state, complex enough for study but not strong enough for rivalry. In this scenario, interventions might prove subtle, such as quietly removing scientists researching breakthrough technologies capable of scaling human energy or inexplicably depleting strategic resources. In summary, the question of whether extraterrestrial beings take interest in humanity depends entirely on their objective functions, perceptual scales, and technological capabilities relative to humanity. If they value complex organic life as a statistical marvel, they take interest. If they prize information and novel problem-solving patterns, they take interest. If bound by cosmic ethical rules of non-interference, they take interest passively. If focused solely on material resources or energy, they likely disregard Earth. If achieved incomprehensible transcendence, humanity's existence might not suffice to attract attention unless causing a major physical event. In all cases, their interest, if present, would constitute a concept far exceeding current human understandings of curiosity or compassion. It would measure in physical, informational, or evolutionary units that humanity can only vaguely discern through the slightest disturbances in the vast cosmic picture. Until humanity possesses conclusive evidence of their existence, humanity remains questioners in an endless vast garden, wondering if the gardeners notice the unique growth of humanity's modest plant. But the act of posing this question, the pursuit of knowledge about humanity's cosmic place, serves as the strongest evidence of intrinsic cognitive value, a value any civilization interested in cognition might recognize.